Here we're looking at normal distribution. Okay, when we talk about things being normally distributed, we would they would fall into a bell-shaped curve like this. So if we plotted how many points we got, uh, we would end up with a curve that looks like this. So this is what's called a normal distribution. Okay, and it's one of those key things you'll hear about over and over again in stats. So normal distribution. Okay, we get a bell-shaped curve. Okay, and it's symmetric. Now when we talk about symmetry, basically we're talking about if we split it in half, we have the same amount on both sides, or it would fold over on itself. Okay, so it's symmetric about the mean. Now remember, mean is just simply the average, and again, we're going to use X bar for that. And then standard deviation. Now standard deviation you should be able to come up with, but standard deviation just basically tells you how close you are to the average. Okay, now the total area underneath this curve is equal to 1. So, and we'll spend some time talking about that in a second when we get to the note-taking guide. But with this, the total area would be 1. Okay, and we'll talk about area and percentages back and forth with this, but if we converted these to decimals, we'd end up with like 0.34 here, 0.34, and we'll do some of that a little bit later on. Okay, but for right now, this is a normal curve. Okay, and most of the information, or not information, but most of the data is going to fall within plus or minus a standard deviation. Okay, now we also have what's called a normal, standard normal, and that's where we convert it to what's called a z-score. And we'll spend more time doing this a little bit later, but with this, standard normal distribution is the normal distribution with a mean of 0. So basically we convert this to 0, and then we know by, instead of having these percentages, we know by if it's 1, 2, or 3 how close it is as far as standard deviation. So, and we'll talk about z values a little bit later. Okay, but for right now you just need to make sure that you understand what the curve looks like, and that this is going to help us to kind of predict things, or the probability of getting certain answers. Now if we look at the workbook, alright, we're on page 245 of the note-taking guide. Okay, and so we have our bell-shaped curves down here. Now remember, the total area under the curve is 1. Okay, so the total area is 1. Now it asks what percentage of the area lies within 1 standard deviation. Now when we talk about 1 standard deviation, we're talking about plus or minus. So if you look down here, we have x minus the standard deviation, and then x plus the standard deviation. So we want to know what percentage of the data falls there. If we add the 34 plus the 34, that gives us 68%. So 68% of the data falls within plus or minus 1 standard deviation. Okay, now if we do the same thing, but we want to know 2 standard deviations, now not only does it take in the part that I shaded blue, it also would take in the purple parts as well. Okay, so it includes this, so it overlaps, so it would be the 68 plus the 13.5 plus the 13.5. Okay, and so we would just total that up, and that would give us the 95%. And then finally, within 3 standard deviations, it would include everything from here up. Let me change colors so we can see that a little bit better maybe. So we're including this. Well, it didn't change. Okay, so we're including this and everything else up to here. We're just not including the little tails. So what we would do is take the 95% and add to it the extra little bit, the 2.35. Okay, twice, because we had a little section down here and a little section up here, and so we would end up with 99.7%. Okay, so most of the information, or most of the data, is going to fall within plus or minus 3 standard deviations. Alright, here we're looking at example problem 1. Okay, now again, it's talking about normal distribution. So we're talking about this bell curve, okay, has a mean of x bar. So this is the average x bar and standard deviation of sigma for a randomly selected x value. So we're going to just go pick out whatever it may be. Later on we'll get into some word problems and examples, but right now we just go pick a data point out of this, and we want to know, this asks, what's the probability that the value we pick out is between the mean and 2 standard deviations. So they want to know the above part. So if you notice, this has already been shaded in, but this is the part we're looking at here. And we're talking about it in terms of area. So we want to know the probability that the randomly selected x value lies between the mean and the mean plus 2 standard deviations. Okay? So to do that, what we're going to do is going to add up the area that falls underneath this. Now, if you remember from the earlier picture, this one's going to be 3.4. Okay, so 1 standard deviation is 3.4. Now, this has been converted to a decimal. It's not in a percentage form right now. It's when we're talking about area or probability, we usually just convert it to a decimal. Okay, and then this area is going to be 0.135. Okay, so 1 standard deviation would be 0.34. Another standard deviation would be 0.135, and then we add those together, and then that gives us 0.475. Okay, so that's the probability that if we picked out an x, that it's going to be above somewhere between the mean and 2 standard deviations away. Okay.